Today we are going to see another solution about predictive asset management. In this solution, we are building a predictive model using IBM's machine learning, which will take the sensor data coming from asset and predict the probability of asset failure so that the asset failures can be predicted well in advance to ensure that asset don't fail. Now this is how it works. We have the historical data where we understand what were the conditions of the asset, what were the sensor data, and in what condition did it fail. Okay. Now, this data is not readily available in new implementation, but from while we are processing and implementing the solution, we create this historical data based on the live sensor feeds and we update the value of an asset whether it's failed or not. Okay. So based on this historical data, we build a model in IBM machine learning. You can also build in the SPSS modeler. Now this SPSS modeler can take inputs either from data scientists or OEMs, which can help define the model, whether it's supposed to use Bayes theorem or decision tree or random decision tree. Basically, there are various algorithms which can be used to create a predictive model. Once that predictive model is created, it gets embedded into an application which is hosted on IBM Cloud. Okay. Now, from your enterprise assets, you will have sensors associated to your assets, and the sensor data gets fed into IBM Cloud using IBM Watson's Internet of Things. When the data comes in, that data is fed into the model which is imbibed in this piece, and based on that it does a predictions. Now, based on the prediction, it takes action. It can create a service request in Maximo, or it can also create a ticket in any incident management or any other MRO software. So that's the basic of this particular solution. The key point over here is this model which we are talking about is a self-evolving model. So as we get the new sensor data and new asset status, that gets fed into the historical data. And as this repository grows in size, it is used to further mature the model, which gets imbibed into the application. Okay, so let me take you to the actual demo. I'm just showing you one of the models which I have built using a sample data which looks like this. What it says is, it takes various factors, and based on that, it says whether the asset was working under that condition or it failed. Now, service due in is a number of days in which the preventive maintenance service is due for that particular asset. Okay. You have leak sensors, you have temperature, humidity. As we also consider the scheduled load of this particular asset. Now, we have taken an example of passenger boarding bridge. That's the reason we have used scheduled flights as a parameter, as well as the precipitation and wind speed. Now, these factors collectively affect the status of an asset. Now, if you observe, in the sheet, we have mentioned various scenarios, as in what scenarios it failed and in what scenarios it was working fine. For example, when the humidity was 84 and the temperature was 55, in that case, even if there was no leak, in spite of that, asset failed. That's one condition. Now, we have another condition where the temperature was 33, there was no leak, humidity was 70, and the asset was still working. Okay? So what happens is, the machine learning model analyzes all this data and creates an algorithm by which, when you give inputs like these parameters, It predicts this value, whether the asset will fail or not. Along with that, it also gives you the probability of that prediction. For example, in order to test this model, I am entering date, service given, rain. If I enter rain as 4 units, so is 0.4, temperature is 35, there is leak, humidity is actually 70, schedule size is like this 50. Now if I click on predict, the model evaluates, it says this, the chances of this being working is 82.86%. Now, what it means is the asset is unlikely to fail. Okay, because the working probability is beyond 80%. Now, case, in this business case, we can mention that if my working probability is anything below 85%, I need to raise a work order. That is something which also can be possible. So model is giving you the prediction. Now, how do you use it is something which I will show you in the next part. So have a look at this. This is a Node-RED editor which is used. Now this is a Node-RED editor, as I mentioned, which is used to call the model on this HTTP request. Okay. Now let me show you this. This is a virtual sensor which I have used. Since this is a video, I was unable to show you the actual sensor, but in practice we will have actual sensors and that data will feed into this. Okay. So now let's say my temperature is right now 24. Now nothing is happening on this side. As I start increasing it, so consider if the temperature is raised to 44, the model is called and immediately it created a work order. Now let me reduce this temperature again. Now since this is a simulated sensor, it keeps giving you data as a heartbeat. It gives data every 2 seconds. But in actual scenario, we can always put in filters like this, okay, so that we don't call this model, the predictive model, unnecessarily. Now if you observe, now this is basically the work order which was generated. Okay. Now let's take a note of this work order 1, 2, 3, 6 and let's check if this is really being generated. 2, 3, 6. Let me check that. Now this 1, 2, 3, 6 was generated by Maxima and it had this summary: asset inspection needed, asset has chances of failure. It was generated on this particular asset 11200 and location BR200. Now this data is basically configured in the payload. In your production system, we can configure this payload as per your usage. So for example, the way it will work is, based on the sensor input data, this payload will contain the corresponding asset. Now, if I have connected this node to say asset number A, then based on the prediction, I will generate a work order or a service request for asset A and not for other assets. That is something which I can easily configure it over here. The key takeaway over here is, if you observe, it calls the predictive model the way we called it here. It gets the score, it gets the probability of a failure, and if the failure probability is more than 60%, then it automatically creates a work order. That is what we saw. If you see, if it says failed and failure probability is more than 60%, only then it creates a work order. Otherwise, if it is less than 60%, it simply says that there is no failure. Now, we can also add a notification node over here. So along with the HTTP service request, we can also send the notification saying that there are chances of this asset failure and an immediate action is needed. Now, in this case, using multiple work orders, that is because I am using virtual sensor. And virtual sensor works in such a way that it, as I mentioned, it gives readings in heartbeats every 2 seconds. But in actual case, we have ways to control it, and this is how it basically works. Thank you.